Reciprocal and quotient identities come from the fact that we know a lot of these functions are reciprocals of different things, like sine is 1 over cosecant, just as cosecant is 1 over sine. And we use that a lot more than we turn sine into 1 over cosecant. But cosine is 1 over secant, but more importantly, secant is 1 over cosine. And tangent, we know as related to cotangent, but we also know that tangent is sine over cosine. And cotangent is 1 over tangent, and also reciprocal of sine over cosine, which would be cosine over sine. And really, it's those ones on the left that are very important. Well, the fact that tangent can be thought of as, oh, sorry about that. Tangent can be thought of as sine over cosine. Cotangent can be thought of as cosine over sine. Cosecant's 1 over sine, and secant is 1 over cosine. So what's going to happen is we're really going to try to turn, tangent, cosecant, secant, cotangent mostly into somehow representations of sine and cosine and see what happens. For example, tangent times cosecant. And now I know tangent is sine over cosine, and cosecant is 1 over sine. And what I say is sine over cosine times 1 over sine. I can simplify this by crossing out the sines to 1 over cosine, and I can leave it like that, or I can then turn that into secant. So tangent times cosecant equals secant. Let's look at another one. Cotangent, well, cotangent is 1 over tangent, or I could think of it as cosine over sine, and I like to turn everything into cosine and sine, so it makes it easier. Secant's 1 over cosine, and sine is just sine, so I'll put it over 1. And what happens when we simplify this? I can cross out my cosines, I could cross out these sines, all I have is 1. So no matter what your angle is, cotangent times secant times sine of that angle is 1.